Hi, welcome back to physics class. Children, in the previous class we studied about force on a current carrying conductor, and also we have studied what rule we had to study in order to identify the force of a direction, means the direction of force. In order to know which rule we have to apply, we came to know. So children, in today's class we are going to learn with a concept called electric motor. In many of our daily life we will hear the word what motor, isn't it children? What actually this electric motor means it's a rotating device children. It actually converts electrical energy into mechanical energy. Got it children? What is mean by an electric motor? It's a rotating device. It's a rotating device which converts electrical energy into mechanical energy. Energy into mechanical energy. Then where can we use this? For example, you can use the electric motor in fans, refrigerator, washing machines, isn't it? Then in the pump set, coolers, electric motor is widely used children in order to convert the electrical energy into mechanical energy. Here you can take it as a rotation children. For rotating purpose, what the mechanical energy is used. Okay, then what are the examples we can take under here? Means in the fans, isn't it? Then mixers, in the pump sets, then in washing machines, etc. Then on what principle this electric motor works? So on what principle this actually works? We will come to know. Children, an electric motor works on the principle of magnetic effect of an electric current. That is, it is based on magnetic effect of electric current and a current carrying conductor. Here we will take it as a coil. A current carrying conductor, if it is placed in a magnetic field, it experiences a force. That is what principle here. That is a current carrying conductor placed in a magnetic field. It experiences what children? Force. See here. Now we will see the actual construction of an electric motor. How it is constructed generally we will look children. See here, in order to construct an electric motor, we need two powerful magnets, isn't it? That is different from the commercial motor. We will discuss afterwards. In general, an electric motor consists of powerful magnets and a coil. That is, earlier we have studied, if a wire, that is if a straight wire or a conductor, if it is bent in the circular pattern, it is called as a circular loop. If it is bent in many number of turns, we call it as a solenoid. In the same way, if the wire is bent in the pattern of a rectangular shape, that is called a rectangular coil children. And the rectangular coil we need, and we have named it as a ABCD. Then we have taken an axle. Upon it, isn't it children, a split rings we have used, and a battery we have taken, then a plug key. So in detail now we will see how the construction of an electric motor will takes place. So children, an electric motor consists of a rectangular coil which is named as ABCD, and the ends of the coil, children, understanding, the ends of the coil are placed upon the split rings, means they are just connected to what here, split rings. And here this coil should be placed between the two powerful magnets, means between the two poles of magnet the coil should be placed. The coil should be placed in such a way that, children, the magnetic field is in this direction, means the coil should be a perpendicular to the magnetic field. Understanding, the coil, what it should be, a coil should be perpendicular to magnetic field. The magnets are in this way, means then the magnetic field will be in this direction. So the coil is what now? It is perpendicular to the magnetic field. And the next one is the ends of the coil. Children, here you have to concentrate very carefully. The ends of the coil, the two ends of the coil are connected to the split rings. Isn't it, children? They are just connected to split rings. Then you may ask, what is mean by here split rings? The split rings are like children, just like a that is a half semicircle, or you can imagine that like that. A split rings or a half rings which are widely used in a electric motor. They are in the form of a ring shape. If the same ring has cut into two equal parts, how it would become? Same in this way. Means half U or semi-circle, you can say. In the same pattern or same shape, the split rings are placed here. And the split rings are internally, they are insulated. Understanding, children? The inner side of these split rings are insulated, and whereas the outer edges of the split rings are just connected to brushes, which we will name it as a X and Y. Means the outer external edges of the split rings are just connected, and the coil is now pressed toward these brushes. The split rings are what? P and Q. Here the split rings P and Q, and it is also called as a commutator, children. You know what is mean by commutator? A commutator is a device which is helpful in reversal of a flow of a current. That we will study in the next, children. The split rings in case of electric motor acts like a commutator. And the brushes, children, which are made with carbon, that is carbon brushes, or X and Y. Isn't it? So what we did, children? The ends of the rectangular coil are pressed just to the brushes. And from this, the coil, that is the ends, are connected to two terminals of the battery. Means one end of the coil is now get connected to the positive terminal, whereas the other end of the coil is now connected to the negative terminal. This is what? A simple construction of an electric motor. Is it clear, children, how to set up this? That is, we need to take two powerful magnets, and between that they have to place a rectangular coil which is named as a ABCD in such a way that the arms, children, here the arms are nothing but the side. This side AB is one side. This is called as a ABR, and this side CD is what? Another side which is named as a CD arm. The arms AB and CD should be what? Perpendicular to the magnetic field, and here we have used split rings called P and Q as a commutator, and the brushes X and Y we have used, and a source battery and a plug key. Now we will see how actually this starts working. Children, now we will study the working of an electric motor. See children, when we switch on the key, the current starts flowing from the source battery, that is from the positive terminal to X, and X to A, B, C, D, and again from D to B, Y it will comes, and similarly it goes to what? Negative terminal. This will continues. But we have studied that when a current carrying conductor is placed in a magnetic field, it has to experience a force. The same thing also happens here also, because an electric motor works on a principle that magnetic effect of an electric current. So here also this coil is experiencing a force, children, isn't it? So we want to know in which direction the force acts. So when initially the current is flowing from ABCD, isn't it children? Initially the current is flowing in this direction. Since the arm AB, see children, this is what? Arm AB is perpendicular to magnetic field. So what happens? The force of direction is what? Downwards. On a arm AB, on arm AB, what is the direction of force, children? Force acts downwards. Isn't it children? How we have come to know this? That is by applying Fleming's left hand rule, children. In order to know the direction of a force on this coil, we have to apply our Fleming's left hand rule, isn't it? The thumb is giving the direction of a force, then index is giving the direction of a magnetic field, and similarly what? The middle finger will give the direction of a current. In this case, the arm, the current is moving upwards, no children? Yes, because of that reason we have to keep our middle finger upward. The magnetic field is in this region and this thumb is pointing downwards, means the force acting on the arm AB is downwards. Similarly, apply Fleming's rule for, that is on CD arm. When you apply, that is Fleming's left hand rule on CD arm, the force is acting upward direction, children, isn't it? So here the magnetic field is in this direction, whereas the force is up, that is downwards. On AB, the force of current, the direction of current is upwards. When it reaches to CD, it is opposite to that of a arm AB, isn't it children? The direction of a current is opposite to that of arm AB, means the current is moving in this way. And where is the force, children? It is acting upwards, means on arm CD, the direction of a force is, force acts upwards, isn't it? This will continues, and here the coil and an axle which is mounted freely at a point will turn about an axis, means at half rotation. These split rings, how means they are rotating now half. The this arm is applying force, so this side what happens? The coil is moving downwards, whereas the CD arm is moving, that is applying force on upwards, so that coil is moving in the upward direction, means this entire coil is now making a only half rotation. It is not making a complete one full rotation, children. So in order to get a one complete full rotation, we have to reverse the direction of a current. Because of that reason, a commutator that is split rings. Here in electric motor, split rings acts like a commutator. Then what is this commutator? It's a device which reverses the flow of current in the circuit. So because of these split rings, the reversal of a current will take place. Means initially the current is flowing A, B, C, D direction. Now because of the commutator, that is split rings, the current starts moving in this way, children. After half rotation, due to these split rings, the commutator will reverse the direction of a flow of current. Means now the coil, that is current, will start rotating in DCBA direction. Isn't it, children? So here when the coil starts, means when the current starts flowing in this way, that is DCBA order, similarly force also should apply on a CD arm and a BA arm. Due to the reversal of a current, the arm CD which initially has moved upwards, it is moving, that is the force applying now downwards. Now what happens on CD arm? The force applies downwards, and the BM is on AB arm, the force is acting now upwards, and on arm AB, the force acts what? Upwards. Isn't it, children? We already studied, due to the reversal of a direction of a current, the force direction also gets reversed. The same thing has happened here, children, because now we have changed the flow of a current in the coil, and due to this reversal of a current, the force also changed its direction. Initially it has moved on AB downwards, now it is pushing the coil upwards, means the force is exerting on upward direction. Similarly on CD, initially it was what? Upward direction. Now the force is pushing the coil downwards. Means it will give us now a complete rotation. Means due to the help of with the help of a commutator, we are getting a complete rotation in the coil. Means initially what happened? The coil and an axle starts rotating half a turn in the same direction. Means it started rotating only half rotation in the same rotation. But with the help of this commutator split rings, the coil has started rotation in what? Complete rotation. Means it has completed now what? A complete rotation. The coil has started rotating completely. Means the main role of a commutator is to give a complete rotation in the electric motor. We are going to use a commutator. Means the main function of a commutator is to reverse the direction of a current. Understand, children, what happened? It's a very easy, children. Only the thing is you have to understand how to apply Fleming's left hand rule on arm AB and on CD, and what is the role of split rings. Initially when the current starts flowing ABC direction, the force on AB is what? Downwards. On CD is what? Upwards. Means this coil is now pushing downwards, whereas CD arm is coil moving upwards, only making a half rotation. Means the coil is rotating now anti-clockwise. what? Anti-clockwise. But with the help of this commutator, now there is a change in the, that is reversal of a current will takes place. The coil which has moved initially upwards is now moving downwards, and similarly the coil which has moved the initially downwards, it is moving upwards. Means complete one rotation will occurs. It means that now complete rotation is possible with the help of a commutator in case of an electric motor. Is it the concepts are clear, children? How electric motor works and its construction and working. So once again, let us revise the concept, children. Electric motor is a rotating device. It converts electrical energy into mechanical energy. This rotation of the coil is nothing but a here mechanical energy. We are supplying a current, nothing but a electrical energy we are supplying, but it is converting into rotation, nothing but a mechanical energy. It mainly works on a principle of a magnetic effect of an electric current, and it has constructed with the help of a rectangular coil and an axle, split rings and a brushless battery and a plug key, and the most powerful the magnets we are widely using. And its working means when the current starts flowing in ABCD direction, that is the force acts downwards on arm AB, whereas the force on CD acts upward direction, means pushes the coil upward. So with the help of a commutator, the reversal of a current will takes place. Now the current flows through DCBA way. In this direction the current starts flowing. When this happens, there should also exist force, isn't it, children? So the initially now the coil has applying force on downwards on CD arm, whereas on AB arm the force is applying upward direction. Means because of this reason, the coil and an axle will make a continuous rotation. Initially what happened? Only they are making a half rotation. In order to make a complete rotation, with the help of a commutator, it is possible, children. So the main role of a commutator is to reverse the flow of a current in the circuit. It is very important, children. In 1 mark you may get the question, what is the role of a split rings in an electric motor? Then you have to write an answer that it is helpful in reversal the flow of a current in the circuit. Got it? Now we will see the commercial motor, how they are used. In order to make a commercial motor, children, we have to replace the powerful magnets, that is permanent magnets, we have to replace with an electromagnets, first point. And the second point says that we have to increase the number of turns. Means when we increase the woundings on the coil, children, we can make the motor as much as powerful. And the third one says that with the help of a soft iron core, that is when we assemble the soft iron core, that is soft iron core on a coil, if it is wounded, means we can make this as a magnetized, and the strength of the magnetic field we can increase, children, isn't it? What happens now? The motor will become a more powerful. So an assembly of a soft iron core and the coil, children, and the coil is called armature. Armature is a device, children, which is helpful, means it is enhancing the power of a motor. You may get 1 mark question, children. Better you can note it down here. Armature is a device. It will enhances the power of motor. It will enhances, means increase the power of motor. So children, when we wound, that is a soft iron core on a coil, the coil gets magnetized, and this now becomes a more powerful, and because of a due to increase in the strength of the magnetic field, an electric becomes now powerful one, and we can call it as a now commercial motor. So in order to make a commercial motor, first what we have to do, children, instead of a permanent magnets we have to use an electromagnets, and a many number of turns we have to wound on a coil, and similarly the soft iron core and a coil, that is armature, we have to insert, and this will helpful in enhancing, means in increasing the power of an electric motor. Got it, children? What consists of an electric, that is commercial motor? An electric and commercial motor consists of all these things.